Hello everyone and welcome to this Autonomous Database course. In today's video, we're going to learn the basics of Autonomous Database. First of all, we will learn what is it and what are the key concepts that we need to acquire in order to start working with it. Secondly, we will also learn about the architecture and also how it works. So let's get started. But before we do that, I would like to mention why Autonomous Database. So what makes this database special and why we should be learning about it? An autonomous database is a cloud database that uses machine learning to basically automate all that is around database tuning, security, backups, the updates, and also some other routine management tasks that were traditionally performed by DBAs. So unlike a conventional database, an autonomous database performs all these tasks and more without human intervention. At this point, you may be wondering, okay, so what is behind the autonomous database? How does it work? What is its architecture? So I would like to explain this really quickly. So when we are using the Oracle Autonomous Database, what we are doing is that we are accessing the cloud-based console. So what we see is a user interface from which we can perform a lot of tasks. But behind this, there is infrastructure, obviously. So first of all, we have the Exadata. Exadata is a hardware that was built by Oracle, and it's made for optimization of the Oracle database. So the structure that this Exadata has makes it a really powerful platform to run databases in. So this is the hardware that we're using when deploying an autonomous database. On top of this hardware, we have the Oracle database with all its key functionalities and also all the options from the Enterprise Edition. And on top of that, we also have machine learning that helps us with the optimizations, failure detection, among some other tasks that we will see a bit later. There are two editions that are specifically tailored to workload for the autonomous database. So Oracle Autonomous Data Warehouse is tailored to data warehousing, data marts, data lakes, and machine learning workloads. Oracle Autonomous Transaction Processing, on the other hand, is tailored to online transaction processing, batch reporting, IoT, application development, and some also mixed workload environments. So I will go a bit deeper on each of them. So the Autonomous Data Warehouse, as the name implies, is related to these data marts and as a part of a data lake deployment. So these systems and databases are generally separated from the transaction processing applications, and these are constructed to meet some specific business needs. So the data warehouses often use data modeling approaches, such as star schema or other techniques, to ensure that the data structures meet the needs of business users when conducting the data analysis. And so that also the data scientists can perform those trend analyses. So these data warehouses typically they have large volumes of data, and this is processed in bulk or streamed into the database. So these data warehouses often rely on summary data representation and highly parallel SQL to provide fast response times. So this autonomous data warehouse is tailored specifically to these use cases. On the other hand, the autonomous transaction processing, ATP, brings basically the same autonomous capabilities found in ADW and also the mixed workload. So ATP is tailored primarily for complex transaction processing workloads, and this includes operational reporting and or batch data processing. But it has the ability to run mixed workloads in a single database, so it eliminates the need to move data from an ATP into a separate reporting or analytics system. So this capability reduces the application complexity, and it also eliminates the wait time that's usually associated with the movement of data. So ADP also supports the IoT and machine learning in addition to standard OLTP. So by automating the creation and management of these databases, this also makes obviously application development much simpler, which is another of the use cases for the ATP. There are two options for deploying an autonomous database. First of all, we have the serverless deployment, which is the one that we will be using in this course to do the practical exercises. In a serverless deployment, multiple users share the same cloud infrastructure resources. So this is the simplest option, and it requires no minimum commitment, and basically you can take advantage of this quick data provisioning and application development features. So you also have included independent compute and storage, and the users are responsible for database provisioning and management, while the provider, in this case Oracle, is the one that takes care of infrastructure deployment and all the management responsibilities. On the other hand, on dedicated deployment, this allows the user to provision the autonomous database within a dedicated, so unshaared, cloud infrastructure. So this deployment model has no shared processor, memory, network, or storage resources. So this offers a greater control and customizations over the entire environment. And it's ideal for users that want to tailor their autonomous database to meet very specific organizational needs. Uh, Also, this model allows for an easy transition from the on-premise databases to a fully autonomous and isolated private database cloud. Both of the workload types that we mentioned before, the data warehouse and the transaction processing, can be provisioned in either deployment option, the serverless deployment or dedicated deployment. Now, let's dive deeper into the serverless offering. So this is a fully managed service, as I said, and Oracle automates end-to-end management of the autonomous database. So it manages the provisioning of the new databases, and also it manages the growing and shrinking the storage and or compute. Another of the tasks that it takes care of is the patching and also the upgrades, as well as the performing the backups and recovery of those backups, etc. So basically, if you are used to doing all these activities, you probably already know how labor intensive and time consuming these tasks are usually. So especially when we're managing many databases. So Oracle automates this all, and this it frees time for you to do other tasks, let's say to use the database in other ways. So you can use the service console to do the full lifecycle management of the service, as I said, from launching the service to stopping it, the backing up, restoring, etc. Or alternatively, this can also be managed by a command line interface or REST API. Let me look now at automated tuning. So in autonomous database, when it comes to loading data, the users can just define the tables and load the data and then start running the queries. So you don't have to worry about any tuning activity, and also you don't really need to have database expertise to perform this task. So another of the things that you don't really have to worry about is creating and managing the table spaces and all that goes around the partitioning, compression in memory, the indexing or parallel execution. Oracle also provides a monitoring console where you can look at the database activity, CPU utilization, amongst the other tasks, also what running statements, which are the queued statements, etc. We also can use the built-in resource management plans. So overall, this is what we could call an load and go service. So we need to worry about very little things, and we can start working straight away. Finally, I would like to mention some of the features of the elastic capabilities. So This means that when you deploy your autonomous database, you can size the database to the exact compute and storage that you required. So there are not any constraints about different shapes or how you can spin up the service. So you can scale the database on demand, and you can do this scaling independently on the compute or on the storage. So also very important to know that these resizing operations occur instantly with the database being fully online. So this means that there is no downtime when these scaling operations occur. Another feature to remember is that you can shut off idle compute to save some resources, and you can restart it instantly whenever you need to access the database. So as well as this scaling that you can do by yourself, you can also enable the autoscaling. So this autoscaling allows the autonomous database to use more CPUs and input-output resources automatically when the workload requires it. So there are tools in which you can configure when you want this autoscaling to happen. So that was it for today. Thank you very much for watching, and see you soon. Bye! Welcome to this next module on the Autonomous Database class. Today we're going to see an introduction to Oracle Free Tier. First of all, what is included in Oracle Free Tier? Oracle Free Tier is a program composed of two main components. First of all, we have a 30-day free trial with 300 US dollars in free credits. Also, we have access to always free services, which are two autonomous databases, two virtual machines, storage, load balancer, as well as access to monitoring tool and notifications. To get started, I will go into my browser and I will type Oracle Free Tier. With this, the first result that will come up will direct me to the website of Oracle Cloud Free Tier. In here, after accepting the cookies, I will see what is included in Oracle Cloud Free Tier. So the services we have just mentioned, the new always free services, as well as the 30-day free trial with 300 US dollars in credits. So now I will click on Start for Free to set up my Always Free account. I'm going to show you very quickly how this process of account creation works. So basically, the first thing we need to create the account is to provide an email address. In this case, I will use a Gmail address, but it could be anything. So after this, I will select the country, territory, and I will click on Next. Now I will select the account type, in this case it's a personal use account, and then I will go on to typing the cloud account name. So this should be some name that it's recognizable for you, that it's meaningful. So in my case I will put Autonomous MOOC. After this I will go on to selecting the home region, which for me, based on my location, I will choose Europe, Germany Central, Frankfurt, which is the closest from where I'm based. After this, I just have to type some more personal information, such as name and address. And once I have logged that in, I will receive a code that in my mobile phone that I will have to use to verify the creation of the account. So this should be pretty fast and straightforward. After I have verified my code, the next step is to introduce a password. This password needs to meet the Oracle security standards when it comes to passwords. So as you can see, they are stated on the screen, but basically at least 12 characters, and it should include lowercase, uppercase, numeric character, as well as a special character. So after I have successfully introduced my passwords, I will go on to the payment information. About this, as we can see on the screen, we won't be charged unless we elect to upgrade the account. So this is very useful information to have, and just keep in mind that they won't charge you with anything unless you upgrade to a paid account. So after this, I will go on to logging in my credit card details. Once I have provided my credit card details, I can finally complete the sign up. As we can see on the screen, now the account is being provisioned. The next thing I'm going to do is I'm going to log into my email account, the one I have provided for the trial creation, and in here I will check the emails. So as I can see, I already have received an Oracle Cloud email saying that my cloud account has been fully provisioned. So in here I can find some access details, such as the cloud account name that I've given and also my username, and then some other data. So I will click on to sign in into Oracle Cloud, and this will take me straight into the Oracle Cloud tenancy that I have created. As you can see here, the title is Autonomous MOOC. Another way to log in would be to go into Oracle Cloud, and on the main page I will look for on accounts sign into cloud. So here I can write the account name, which is Autonomous MOOC, and clicking on next I will get to the same page I have just showed you. So these are two ways that you can log into your tenancy in Oracle Cloud. So I will provide my username as well as my password, and I will log in. Let's give it a few seconds. And okay, perfect. Here we are. This is the main console of Oracle Cloud Infrastructure. So as you can probably tell, this is currently in Spanish. So the first thing I'm going to do is switch the language to English. This should only take a few seconds. So okay, perfect. Here we are. We are now inside our cloud tenancy. There are multiple things that we can see here. The first is the hamburger menu that we can find on the left top corner. And in here we have access to all the different services that we can use within this tenancy. Okay, so this is it for this video. Let's stay tuned and see you soon.
Welcome to the video Oracle Cloud Tour and Autonomous Provisioning. In this video, you're going to see an introduction to the Oracle Cloud. We are going to check the main differentiators of the Oracle Cloud, and we're going to go through a typical architecture or an overview architecture that you can build on top of the Oracle Cloud. Then, after this short presentation, we will go directly to the graphical interface so we can start working and testing it directly, in which we will create a virtual machine and autonomous database. But before that, I want to share some terminology which is important before working directly into the Oracle Cloud. So one term which is very important to know is the concept of the Oracle region. Which is an Oracle region? Typically, it's a city, for example, could be Frankfurt, in which Oracle provides 3 different data centers. So these 3 data centers are called availability domains. These 3 availability domains or data centers are interconnected between them, so it is very easy to create any kind of architecture. So for example, if you want to create a disaster recovery of a database, or you want to create a big data cluster, or you want to create a NoSQL cluster, and so on, you can take advantage of these 3 data centers, which are completely free of use. I mean, the connectivity or the network among all these 3 availability domains is completely free. So you don't have to worry about this kind of architectures, because all the resources that you use among all the 3 different data centers are completely free. Let's have a look on a typical Oracle Cloud architecture. So you can see that, for example, we want to create, for example, different virtual machines in which we're going to use the 3 availability domains. So in this case, as you can see at the bottom, we have the concept of VCN or Virtual Cloud Network. So we have the possibility to create a network per availability domain, or a network which will go through the 3 different availability domains, which is the case of the picture. So in this case, we can create this architecture that I mentioned before. For example, the 3 different nodes that we see in the picture could be a NoSQL cluster, which is built on 3 different availability domains of data centers that are in a distance among them between them of 10 kilometers more or less. But the latency is very, very low, and you will not notice that you are using 3 different data centers. Also, for some customers that they can't use the cloud completely, or they want to keep some application on premise, they can create a VPN, or for example, they can have a dedicated connection in which they can extend the local data center to the Oracle Cloud. So in this case, the Oracle Cloud will be an extension of their local data center through this dedicated and private network. So with a guarantee that there's not a public IP where, for example, a hacker can go through. So this is very important. So when moving some applications to the cloud, it means you can do it little by little and not having architecture of everything or nothing. No? You can have an hybrid architecture. But why you should use Oracle Cloud? Which is the main differentiators of the Oracle Cloud? One of the main reasons is that the Oracle is providing a hard partitioning when creating VM or any kind of PaaS service on top of the Oracle Cloud infrastructure. So this is the meaning that when you create, for example, a virtual machine, you can have different OCPUs or Oracle CPUs. These CPUs are completely dedicated to the Oracle customers. It means that, for example, when you create a VM with one OCPU, this core or CPU is going to be completely dedicated. It means that you will have 2 threads completely for you, and they are not going to be shared with another customers. So for example, if we go to another cloud provider, they have what we call a virtual CPU. It means that this core is going to be shared among another customers. If you wanna have the guarantee that the performance is gonna be constant in time because you have an enterprise application, then it's recommended to use the Oracle Cloud. With this hard partitioning and this performance that we can guarantee in the CPU, we can have an enterprise SLA. The SLA is different with other Oracle Cloud providers because the first thing that we cover is the availability. So if you have an SLA, for example, depending on the service, that you have a 99.95 of SLA, you can have the guarantee that this VM is going to be up and running during this time. We have another topic covering the manageability. So what is the meaning of manageability? So for example, let's assume that you have an architecture in which you have different virtual machines, and you want to stop this virtual machine during the weekends to save money because there is going to be nobody in the company during the weekend. If for any reason you cannot access the graphical interface, or you cannot stop the VM via a REST API or any kind like that, you will be covered by the SLA because you will be charged because you can't stop the VM. So you're covered by that. And thanks to the hard partitioning, also in the performance, you are covered because in case that you think that the performance is not estimated in which you have in the contract, you are completely covered, and all the details are public available in the Oracle Cloud webpage. So let's go to the graphical interface and let's start working. Okay, so we just log in into our Oracle Cloud account. And here what you can see is the main page of the Oracle Cloud. So here is the first thing they want to see after you log in. The first thing to notice is, as we saw before, we selected Germany for our trial account. You can select another region or another data center through here, but for this demo, we're gonna keep the Germany Central or Frankfurt. Also, if you want to change the language of your graphical interface, you can do it through here in case you want to change it to another language, okay? But we're going to keep it in English. So we just are here and we want to create, for example, a compute and an autonomous database. But we have to do a few things before we go through that, okay? So we have to go through the burger menu here, and you will be able to see all the services that Oracle Cloud is providing right now. So for example, we have the compute. So we'll go here later on to create our VM. Or for example, networking, we need to create a virtual cloud network in order to deploy our virtual machine. But we have to go to the identity part, because here we already have a user and we are in the admin group by default because we are the first user and we are the administrator. We have to create a compartment. So what is a compartment? A compartment is a logical zone where we can split our resources. So for example, let's assume that you want to have a development completely split from production. So in this way, with a compartment, you can create a compartment for production or you can create a compartment for development. So you can create resources as VM, databases, and so on, but also different users and groups and policies depending on the compartment. So this is very useful when your architecture is growing. So we're not going to create our compartment before we create a VM or the autonomous database. So as you can see here, we have already a compartment, which is, for example, what is called the root. For the root, it should be used only for the administrator in order to create more resources, as for example, could be the policies, users, groups, but nothing should be really deployed on the root because it's not a best practice. So in this case, what we're going to do is to create a new compartment. Let's call it, for example, autonomous compartment. And let's give it a description. Okay. So also we can select or create more tagging and so on, but for this case it's not required. So let's set a create compartment, which is just immediately. So now that we have our compartment, we can create a network. So before we create our configuration or architecture. So in this case, we'll go to the networking part and we select the virtual cloud network. Even if you don't have experience in creating network, you don't have to worry because we have a wizard that is going to help you to configure the network configuration. So also it's very important that for any action that we do in the Oracle Cloud, we should select the right compartment. So in this case, we have to select the autonomous compartment because we want to create a virtual cloud network inside of this compartment. So let's go to create our VCN. As you can see, we have two possibilities. One is to create just a simple VCN and to have also internet connectivity. And also we have the possibility to create also a VPN to our local data center. So in this case, we're going to select the first option to create just a VCN with internet connectivity. The first thing that we have to give is the name of our network. For this video, we're going to create, for example, autonomous VCN as an example. The compartment, which is the right one, the autonomous compartment. And if we go down, we can see that we can configure already our public and private subnet. We have here an example of configuration already created, and we are going to keep all this configuration for us. Okay, so we can create this VCN just by clicking by Nest, and we'll have the summary of the networks that are going to be created. In this case, it's going to be created through all the three availability domains. And also, this wizard is going to create for us the internet gateway, a NAT gateway, and also a service gateway. So it's so easy and so simple. So let's click on create, and automatically it's going to create the VCN for us. So we are able to provision new hardware or new VMs or new autonomous databases. So let's go to the main page again by clicking the Oracle Cloud logo, and let's create, for example, our first VM. So we can go to the compute part and we can click on instances. So again, we verify that we are in the right compartment, which is the autonomous compartment, and let's create a new instance. So for example, let's create a Linux machine for installing anything that I want. No? So for example, This is my name, Linux machine. Let me choose a different operating system. For example, I want to select my CentOS 7. Okay, I select the image. And here I want to select the advanced options. So for example, let's assume that I want to create in the availability domain 1. As we mentioned before in the presentation, I want to create a virtual machine because I want to select the number of OCPUs that I want. If I select a bare metal, it's going to be a full blade of 36 or 52 OCPUs just for me, and I can bring also my own hypervisor if I want. And I want to select a new VM. Let's, for example, choose the VM22 because we'll have two CPUs with 30 gigabyte of memory. Okay, I select the shape. I select the compartment, the network. I want to select the subnet compartment, which is this one. I also want to select the public subnet because I want to assign a public IP. Okay. Also, the last thing that I want to do is to paste my SSH key, my public key, in order to connect here. So in this case, as I'm using a Mac, I can use my terminal in order to generate directly an SSH key. So for example, with this command, which is the SSH keygen, I can generate my private key. I will keep it this like all out of the box. And here I have my public IP. I'm gonna do a cat because I'm gonna copy and paste directly here. So I can connect later on. So once I have this, you can see it's very easy. I can just click create and the virtual machine is gonna be created. So and it takes just a few minutes to create. Here you will see all the information that is automatically created. For example, the private IP is already generated, the compartment, the shape, the VCN, and everything. And here we can see that it's already creating it. And also, for example, once it is created, I can even change the shape if I, for example, want to use more or less CPU depending on the workload that I need. Okay. Also here in the bottom, I have some metrics, but also I can create, so for example, some block volumes in case that I need more storage. I can create it, and it will take just a few seconds more. And once it is created, what I will do is to create an autonomous database directly. Okay, so you can see here that it's already created, and even if I go through the terminal, I will be able to connect via SSH if I want. But let's go to the most interesting part is about how to create an autonomous database. If I go back to the burger menu, I see here that I can choose between the two autonomous databases, or the autonomous data warehouse, or the autonomous transaction processing. In this case, I'm going to select the ATP, the autonomous transaction processing, where I'm going to create one directly. So again, I verify the compartment where I am, and I will click on create an autonomous database. I'm going to create the autonomous database. I will give it a name, for example, ATP, which is the logical name that is going to be displayed in the graphical interface. But the database name, I'm going to call it URCL, for example, of the Oracle database. I will select a transaction processing mode. I will select the shared infrastructure. I select the database version. I will select the 19C, which is the recommended version because it's going to be the long time support version. The number of CPUs, I will keep it to 1. Also 1 terabyte of storage, which is the minimum. And also here, I have the possibility to select the auto-scaling. So for example, if I have a huge workload with this one CPU, with the auto-scaling, it can grow up to 3 times the size of the CPUs that was already configured. So in this case, if this one CPU has a huge workload, automatically it will go up to 3 depending on the workload, and then it will go back to 1. Okay, so you can configure the auto-scaling so you don't have to worry, for example, during a weekend in case that you have a workload. Okay, so the default password is admin, the username, sorry, and I have to select a new password. For example, let's create a new password. Okay, and here also I can select to go directly to have a public IP directly without configure any kind of VCN, or I can configure even inside of my VCN in case that I want to have a private IP for my autonomous database and so on. For keeping it simple for this tutorial, we're gonna select the first option. So it's gonna be easier for you in case that you want to connect, for example, via a SQL developer, or you want to connect a local application from your desktop and so on. So let's select this first one. Then we select the option to include the license because I don't have a license for the autonomous database. And then automatically I can create the autonomous database, and this will take around 5 minutes to create. Okay, so this is how easy it is to create an autonomous database. So in the next videos you will learn more about the autonomous databases.
Hello and welcome back to another module in this Autonomous Database course. Today's video is about basic administration in Autonomous Database. In this video, we are going to learn about scaling. Then, we're going to learn a bit more about the predefined database services that are available on ATP, Autonomous Transaction Processing. After this, we will see how we can easily connect to our database, and finally, we will see how data importation is made. Let's begin with scaling. I am in the Oracle Cloud Infrastructure console, and I am currently in the console for Autonomous Transaction Processing. So as you can see here, there are many different options on what I can do. We have database connection, we have the service console, we could scale, and we could also do some other actions. What I'm gonna do is that I'm gonna scale. So in this case, I have 2 OCPU count for this database. So what I'm going to do is I will decrease this to 1, and I will leave storage as it is. So after updating, this should only take a few minutes or even seconds. As you can see in the lifecycle status, the scaling is in progress. So this will change once our database has been scaled. As we mentioned in the introduction to Autonomous Database, it's important to know that this scaling can be done independently the CPU from the storage. So as you see now, what I'm going to do is I'm going to scale back up. So I have put 2 OCPUs count and then 2 terabytes of storage. So this is completely independent. There are no predefined shapes or any kind of configuration that we need to stick to when it comes to scaling. So after this, scaling is in progress, and now we should be able to see how the OCPU count has gone. Okay, there it is. It has gone back up to 2, and also we have 2 terabytes of storage. Moving on, now I would like to speak about the predefined database services for autonomous transaction processing. So we are provided with a credential zip file that contains 5 different database service names. So these are identifiable as TP urgent, TP, high, medium, and low. So these predefined service names, what they do is that they provide with different levels of performance and concurrency for the autonomous transaction processing. So I'm going to go a bit onto each of them so you are aware of what the implications are. The first one, TP Urgent, this is the highest priority application connection service. So this is for time-critical transaction processing operations. Important to know that this connection service supports manual parallelism. Then we go on to TP. So this is a typical application connection service for transaction processing operations. this connection service does not run with parallelism. Okay. Then we have the high. So this is a high priority application connection service that is thought for reporting and batch operations. All the operations run in parallel and they are subject to queuing. The next one would be medium. Medium is a typical application connection service for reporting and batch operations as well, just as like the high one. But here, all operations run in parallel and are subject to queuing as well, but the degree of parallelism of this service is limited to 4. Finally, the low. This is the lowest priority application connection service, also thought for reporting or batch processing operations. So this connection does not run with parallelism at all. So once this is clear, we're going to move on into connecting to ADP. So for this section, we're going to go through different steps, and these basically are accessing the credentials so obtaining the credentials for connecting to the ADP, and then we will perform some connections that we will test. So I am on the Service Console for Autonomous Transaction Processing. So I have clicked there, and here I have the dashboard with the different things I can do. So clicking onto administration, I'm gonna download client credentials, so the wallet. So by clicking here, I will have to enter a password before downloading this wallet, which is a zip file that contains their credentials. So I will set the password and I will download these credentials. After this, the next thing I'm going to do is I'm going to open an SQL developer. So I will just open the tool. Once I'm here, I will click onto create a new connection, since this is what we're doing. So on the top left corner, I will click create a new connection and I will fill in the details. So I'm going to call this connection admin low, and I will define the username admin, and I will give the password that I had provided before for this username. So I will type that in, and then I will go onto choosing the connection type, which in this case is a cloud wallet. So I will choose the file that I need, and then I will have to choose the service. These are the services that I was talking about before on this video. So as you can see, I have high, low, medium, TP, and TP urgent. I will start with creating a connection for low, and I click in test, you see that the connection is a success. So status is success. So once I have done this, I can go on to saving this connection. So I will click on save, and then I'll be able to actually connect. After clicking connect, I will get a message to put the password for the admin user again. So I will do that. And then, as you see, we are connected. Okay, so what I'm going to do next is that I'm going to create another connection, but this time it will be with the database service high. So I will click again onto create a new connection, and I will fill it in just as I did before. So all the fields will be exactly the same, excepting for the database service. So as you can see, I'm putting again admin and password. I will choose the connection type, which again it's a cloud wallet, and I will browse the zip file that I had downloaded. So now onto service, I will choose Oracle High. And with this, I'm ready to test it. As you can see, it is a success, so now I can save it. And once I've saved it, I can connect, or in this case, I'm not going to connect. I will just leave it there. Okay, so now I have my two connections with the services high and low created. So what I'm going to do is do some tests on this connection to see the difference on the performance. So what I have is that I have in my notes, I have some code to run on this worksheet. So I'm going to just paste it, and as you see, these resources are provided. So you can see that the code's working fine, and you can see that this fetch 50 rows was implemented in 0.504 seconds. So now I'm going to do the exact same process to run the same query for the admin high instead of the admin low. So as you can see, first I need to connect to the admin high connection using the admin high connection. So it will ask me to introduce my password. Okay. And now I will get the worksheet for this admin high connection. So I will go again onto my notes, I will copy paste this code, and I will paste it and run it into the worksheet. Once the query has been run, as you can see, we get the query result. And if we look into the timing, we will see that the 50 rows were fetched in 0.324 seconds. So this is lower than 0.534 seconds. So this is how we can see the difference between the performance of the low database service and high database service. So the next thing I'm going to do is I'm going to load a local file into ATP. So we're just going to load a file, .csv file into the ATP, and we're going to use the SQL loader. So as you see, we have clicked into import data, and now I am selecting the data that I want to import. So I will open the file, and as you see, we can see a preview of the file contents, and I will leave everything by default. I will do the same with the import method. I'm going to do an insert, so I need to write the table name that I'm going to call sales low bar channels. So I will click onto next, and then I will choose the columns. All the columns are selected, so I will go on to the next step. Now I'm looking at column definition, and I'm gonna leave everything default. But as you can see, we could do some changes into the data type, and depending on the data column. So I'm just gonna leave it as it is, and I will click on next. And finally, this is the last step of the wizard, and I will check everything's correct. So I will click on to finish. So we can see that immediately we get a message that the task was successfully completed. So the importation was done. I will just do a very quick text. So I will run a query to see this newly created table. So as you can see, I am doing select all from sales channels, the name I've given it. So once I have that, I will run it. And here we get the query results. So this is it for today. These are some basic steps on the administration. Thanks for watching, and see you soon. Bye!
Welcome to the video Oracle Autonomous Hot Scaling with SwimBench. In this video, we're going to learn how the autonomous database scale, increasing or decreasing the number of CPUs under demand. Then, we are going to simulate a workload using the Oracle Cloud Shell and the tool SwimBench. Finally, we're going to scale the autonomous database while running a workload generated by the SwimBench tool. So, what is the autonomous scaling? It allows us to increase or decrease the number of CPUs. It doesn't matter the number that we choose. This scaling is a hot scaling, so we will not have any downtime during the scaling. It doesn't matter if we increase or decrease that number. We'll show it later how to do it. Also, we have the option of auto-scaling, which allows the autonomous database to increase the number of CPUs if the current configuration is reaching a big usage of the database. Without scaling, it can grow up to 3 times the current configuration. So for example, if the current autonomous database has 2 CPUs and is reaching its limits, the autonomous database will increase those CPUs up to 3 times, so it means 6 CPUs, depending to the workload that is currently running. And also we're going to use the SwimBench tool. But what is the SwimBench tool? It is a load generator tool. It is an open source tool which is created by the Oracle product managers and which is free to use. This tool is going to help us generating a dataset and a workload that we're going to use in this video. So let's go to the demo time. Okay, so we are back here in our cloud environment. And the first thing that we need to have a look is the SwimBench tool. This is the official webpage of the SwimBench tool that I show you during the presentation. It's a tool which is going to help us for the data generation and the workload simulation. So I'm going to download it and use it while doing the hot scaling of the autonomous database. Okay. So the first thing I will go is I will go to the autonomous transaction processing to have a look into our database, which is here. And then the next thing that I'm going to do is to open the Cloud Shell. We're going to use the Cloud Shell to download and use this tool, the SwimBench. This Cloud Shell is more than enough to run this workload simulation, as we just want to show how is the scaling working. Okay, so we don't have to use any kind of VM or doing anything like that. So we can use this already feature available into the cloud. So once we have it, while it's loading, what we're going to do is to download the SwimBench, okay? That can be downloaded from here. And what we're going to do is to copy the link because I want to download it using the tool wget. And with this tool, once it is downloaded, I will unzip it and I will run it, okay? So we can see that we can run some commands, okay? So I'm gonna download the SwimBench tool to start using it. Also, something that we'll need later on is to use the Oracle Wallet because we need to connect to the Autonomous to generate the data and also to generate the workload. So after we download it, we're going to unzip this file. So we have it here. And the next thing that we're going to use is to generate or download the wallet here into the Cloud Shell so we can connect to the Autonomous. So for that, we're going to use the OCI CLI, which is already configured for our environment. So with this OCI CLI, we have all the commands ready to use so we can work directly with the cloud. So for example, we can work for the analytics, we can work with the compute, with our VMs, we can work with the data science, and also we have the autonomous, so we can work with it, okay? So I have here the command for creating the wallet automatically. I will copy and paste the command. I will explain it, and also I will keep it here in the video description in case that you want to use it, because I think it's much easier to understand. Okay, so what we're going to do is using the OCI CLI, we're going to work with autonomous database, and what we're going to do is to generate a wallet. Okay, also we're going to be asked to define which is the autonomous database in which we want to generate that wallet. Okay, this is the identifier of the autonomous. So we go here, we'll see that we have here this ID, OCID, which is the same that we are using here that already prepared this script. Also, we are going to define a password for the wallet, and also we're going to define the name for the wallet, the file. Okay. And we will see that here we have the wallet already here that we're going to use to work. Okay, dbwallet.zip. Then what we're going to do is to generate some fake data into the autonomous database, so then we can simulate this workload. Okay, so I will go to the swimbench directory, and here in the bin I have all the different commands for generating, for doing workloads, and so on. And we're going to use a tool which is called the OE wizard that is going to help us to generate a workload. Okay. Also have the script already here prepared. Again, I will keep it here in the description so you can use it, and it's easy to copy and paste. And this OE wizard, we have to give the next information, okay? So we have to provide the wallet location that we downloaded before. Also, we have to define to which connection do we want to connect, okay? In this case, instead of TP, let's do, for example, TP urgent. As you know, there are different kind of connections depending on the workload that you want to use. In this case, as is a lot of transactions for just inserting data, we're going to use the TP urgent. Then we have to define the table space. That in the autonomous we have just one, which is the data table space. We have to define the user and password for the admin. Then we have to define the new user that we are going to create. In this case, the user SOE with this password. And finally, we have to define how much data will generate. So it's half of a gigabyte just for demo purposes. Okay. So we will see that automatically it will start connecting to the database. And once it is connected, it's gonna start generating some workload. We will see also a percentage which is going to tell us how is the data generation going, so we can more or less estimate how long it's gonna take. So after the data is created, automatically the script is going to run some statistics and create some indexes that is going to take some time. So as it's going to take a few minutes, what I'm going to do is to cut the video, and once this percentage is completed, we'll come back and we'll keep continuing with the video. Okay, so the data generation has finished. We have here the information that all the tables has been created successfully. So once everything is done, what we will have to do is to generate a workload. Okay, and for that we're going to use another utility which is called the chart bench, which is here. I have here also the script that you can copy and paste. Also, I will keep it there, which is going to allow us to easily generate a workload. So let's see the configuration. So the first configuration that we have a parameter that we have to provide is a configuration file. This configuration file has some information about which kind of queries do we want to run, and how often or which weight has each query, so we can simulate a workload. So here, I'm going to use an example which is comes out of the box, but also you can generate your own workload just changing or creating your file. Then we're going to use again our wallet to connect to the database. We're going to connect with the TP urgent connection. We have to provide the user and password, and then we want to show some information about how many users and transactions per second we are running to have some information in real time. Finally, we have to define the number of users that we're going to be running and doing queries in parallel. So for this example, we're going to use 64. So let's go into execute it, and it's going to start running. So the first thing that it's going to do is to generate or connect all the 64 users. And once that we have all the 64 users, it's going to start running these transactions. Okay. So the first column are the transactions per second. So here we can see the number of transactions that we are running. So around 1,000 transactions per second, 1,300, and so on. So as we have this workload, what we're going to do is to scale directly. So let's do, for example, 4 OCPUs directly. Okay. So let's update with this configuration. This configuration is going to take a few minutes, but most likely we'll see here in the cloud cell first that the number of transactions increase and before it's already completed. Also, we have to consider that the auto-scaling is not going to work here, although it was enabled before, because the workload is not enough. Okay, so we're not to see a huge workload into the CPU. Okay, so it's gonna be rephrasing to see if you see some workload, but we'll see that the CPU is not going to be too much. But here, look, we can see already the increase. So we have 5,000, 6,000 transactions per second. So we can see that this transaction is increasing, and this is before due to the auto scaling, because now we have 4 CPUs instead of 1. So once it is over, we're going to go back to 1 CPU, and we're going to see how it decreases. 1 CPU, and I'm going to update it. As you can see, we don't see any kind of timeout, any error with the query. Okay, here we have an error, but it seems that the random data which is generated doesn't like it. And we saw that we're going back to 1000 without any kind of timeout. They cannot connect or something like that. We have this issue that sometimes happens, that it doesn't like the data because it generates random data for the insert and the update. But we can see how it is working. With just clicking, going with the Control C, we can stop the workload generation, and this is how we can show how the scaling up and down is working with any kind of downtime. So thank you for watching this video, and I hope to see you in the next one. Welcome to the video about how to validate your database before a migration. In this video, you're going to learn how to do this validation before migrating to the Oracle Autonomous database. Then we're going to validate an 11G database using the Oracle Cloud. How are we going to validate a database? Oracle provides a tool which is called Schema Advisor. This script provides a report with information about the database and any kind of issue that you will find in the migration. In the first part of the report, we're going to find a summary of all the objects found and if it is possible to migrate it or not. Then we'll find more detailed information as the objects that can be migrated, objects that will migrate with modifications, and finally, a summary with the best practices. How do we find these scripts? We can find it at the Oracle support with the following doc ID. You will find two files. First, the script itself, and second, a small PDF guide about how to run it. But you don't have to worry because we're going to run the scripts together. So let's go to the demo. Okay, let's run the script over the 11G database that I have. So the first thing that we have to do is to get the, the files from the support node. Okay, here is the Oracle Autonomous Database Schema Advisor with this node, and here at the end you can find all the scripts and all the information about how to run it and what is contained. No? And basically we have two main files. The first one is the script itself to run over the database, and then a small PDF guide about how to run it. But don't worry, because we're going to do it together. So here I have, using the Oracle Cloud, I have an 11G database that we are going to use in order to run the script to see if I can migrate it to the autonomous database. So let's go to the VM database, VM part for the platform as a service. And here you can see that I have an 11G already created. If we go here, you will find all the information about my 11G database. And here in the node part, I have the IP address because I'm going to connect via SSH to the machine in which I'm going to run this script. Okay, so this is my public IP. So I'm going to use Termius to connect, which I have already configured with the public IP and my private key also. And I will connect with the other OPC, which is the Oracle Public Cloud. So the first thing that I'm going to do is to connect with the Oracle user, and I will go to my home. Here, I already put the script, okay, that I uploaded, so we can run it directly and see how it works. So this script has two main parts. So the first part is to install the script itself in a new schema, specific schema that we create under demand. And then we're going to run the script to see the output and to see if I'm able to migrate it or not. Okay. So for that, I'm going to have to run it as sysdba, the command in which I have to define the script to run and the new user or schema that I'm going to use. Okay, so I will connect to SQL Plus as a sys. With my password as sysdba. I'm gonna install adb advisor.sql. I have to define the user, so my advisor, for example, and then I have to define the password. So for example, this one. Okay, so once it is created, so we have to connect here to run the script. So we have to connect to the my advisor with my password. So I'm gonna define the output in order to see it correctly. This also is explained in the documentation in the PDF. And now I'm going to run this command, which is like this. So exec the adb advisor dot report, in which it has two parameters. First is the schemas. To which schemas, which schema I want to migrate. So I want to validate that specific schemas. So in this case, I'm going to define all the schemas. Okay, I wrote it wrong. Schemas. Okay, I define all the schemas I want to run it. Okay, and the type of the autonomous database. So as in this case, I want to migrate just a serverless ATP. I will run ATP. if I wrote correctly, we'll be able to see the report. So let's go to the beginning to the report, okay? So here I have some information about the database that we run. So we can see that it's a 11G database. And here we have a summary of all the objects that it found and which kind of issue we can find. No? So we can see that we have 47 indexes, we have 50 tables to views. And here in the second column, I can see that I'm not going to have any issue to migrate it, although there are some objects, okay, in this case some tables that will migrate with some changes, okay. So let's have a look to which are the issue, okay. So in case in the section 2, in case that we have any object that we cannot migrate, it will appear here and the reason why. Then we have information about the tables that will migrate with changes. Okay, so in this case we have some tables that were configured with the no login because maybe we don't want a backup or something like that. But in the autonomous database, everything will be with the login. Okay, so during the import, automatically it will create the tables with this configuration. So we don't have to worry, but we have this warning saying that these tables will be modified in the sense with the login. Okay. More information we have here, for example, some additional info. So the parallel degree. So it seems that for some indexes were configured with some specific index, it's better to change the index to define the number of parallel that we want to run. But we don't have to worry about this because automatically we configure by default, so we can run it in parallel, okay? But anyway, you can change it manually if you want to do it, for example, here automatically. Then also something very important is that we don't have table spaces as we know it. So we have just a unique table space, which is called data. So we are not going to be able to run, for example, the SOE or the user table spaces. So there will be a migration of the table spaces. So we have to be aware of this information because we can't manage the table spaces in the autonomous database. So it's the Oracle in charge of managing the table spaces and so on. So everything will be migrated under the data table space. Here also we have the warning that all the table space from users or sysaux and so on will be migrated to the data, which is the same information that we were telling us as before. And finally, what do we have are some parameters that were detected and they are not possible to modify in the autonomous database because it's Oracle in charge of managing the database. And here we have a look, okay? So for me, it doesn't matter because I have just the data and tables as schemas and so on. But in case that you have some specific parameter, please review all these parameters. And also in the documentation is provided, you can see all the parameters that can be modified and which not parameters can be modified. So this is the end of the report. So we are ready to start exporting the database and then to upload it and migrate it to the autonomous database. Thank you for watching. Welcome to the video about how to migrate your database into an autonomous database. In the video before, we learned how to validate your database before the migration. As our database is compatible with Autonomous, we're going to see the steps for the migration. First, we're going to generate an export of the database. Then we're going to upload the export to the object storage in the Oracle Cloud. And finally, we're going to import into the autonomous database. There are some considerations about the export and the import. The recommendation is to do it via schemas. In this video, we're going to export one schema and then we will import that specific schema. In order to make it faster, you can configure different levels of parallelism in order to import several schemas in the same import. Also, it is recommended to read the documentation carefully about the best practices for the export and the import. After the data is exported, we're going to use the OCI CLI to upload the export into the object storage. As it is not installed on the machine where the export is generated, we're going to install it there. OCI CLI has several advantages as it can partition a big file and upload it in parallel. Once the export is in the object storage, we need to define the credentials. With these credentials, the Autonomous will be able to access the object storage. Then we will open the port 1522 as it is the default port in the Autonomous database, so we can run the import. And then finally, we're going to use the Cloud Shell as it comes with a SQL client, and we're going to use that specific client to run the import. So let's migrate the Autonomous database. Okay, so let's export this 11G database that I had before into the into an autonomous database. As we saw in the last video, this database is already validated, so I know they can migrate this database into an autonomous database. So the first thing that I have to do is to generate an export. So I'm going to connect to my 11G database for that purposes. So I'm gonna connect as the Oracle user, so I can run the export, okay? And also what I'm going to do is to define the directory in which I wanna do the export, okay? So I have a directory already here that I have chosen in order to make it easier. So here on this directory is where I want to do the export of the data, okay? So what I'm going to do is to connect as this DBA. So I'm going to define before doing the export where I want to run the export, which is in the file before, okay? So for that purposes, what I'm going to do is to create a directory. Create directory, PDP, for example, there as 01 directory. Okay, I have my directory. So also what I want to do is to run the export for the SOE user or schema that I have already there. So what I'm going to do is to give some privileges to that specific user, okay? I'm gonna grant read and write on the directory before. Directory to SOE user. I'm gonna grant data pump database to SOE also, and the impdp. I want to make sure they have some extra privileges to make it work properly. The pump for the import from to SOE. Okay, so now I want to create that specific export, okay? So I'm gonna run the tool, which is spdp. To run the export, I want to export the SOE schema. I will define later on, so we'll connect with SOE. I will put the password. As per the documentation, I have to exclude some things. Okay, I'm gonna exclude the cluster DB links. So as I said in the presentation, please read carefully the documentation about the export and the import. Okay, I'm gonna export the SOE schema one. I'm gonna define the file, dump file, for example, export.dmp, and the directory that I'm going to use is, for example, is pdp dump there. Okay, so if I didn't miss in anything, I'm gonna generate the export in the specific folder that I define. The schema is little, so it's gonna take not so much time. Okay. So meanwhile, it is exporting, so we need to prepare the cloud in order to get this import. Okay. So what I'm going to do is I will go to the object storage. I'm gonna define a bucket in which I'm going to create or upload the export. Okay. So for example, I'm gonna call it DB from database because I'm gonna receive the export database, and that's it. I will keep the default configuration. So I have it already there. So let's see how is the export going. Okay, I see that it's already there successfully. Okay, I wanna check because I want to be sure that everything is there. Okay, here I have my export. I will go back to my home because now that I have the export there and the object storage is already also prepared to upload the data, so I need to upload it. Okay, so for that purposes, what we're going to use is to use the OCI CLI, and there is an installer. Okay, there is a documentation which explains how to do it, and we're going to do it together as it is very easy to do. Okay, so what we're going to do is to copy this script. So it's going to be downloading this script for installing it. Okay. So if I paste it here, it's going to download it and install it. So we're going to keep the default configuration of the OCI CLI to where to place the directories and the scripts and everything. So we'll keep it in the home directory. You can choose any other folder, okay? And this is gonna take a few seconds. So after it is downloaded, we need to configure or synchronize with our tenant, okay? So we need to say or tell to the OCI CLI to configure with our tenant. So for that, we have to run a specific command, which is OCI setup config. And we are going to have a wizard which is going to help us to synchronize the CLI and the our cloud. Okay, so I want to have it in our path, so it makes it easier. The default profile and everything is there. Okay, so now that it's installed, what we're going to do is to synchronize, as I was saying. Okay, so OCI setup config. And we're going to be asked for some configuration. So for example, the default folder is the .oci config, is fine. We need to define the user OCID, okay? So we have to go to our tenant and go here to our user. And here in our user, we have the OCID, okay? So we can just copy and paste. We have it here, so we can copy from our user and I will paste it. As the same with our tenant, which is our cloud account. So if you go to our tenancy, we have it here. So we can just copy this long string and to put it here. Okay. Now we need the region. The region that we're using is Frankfurt, as you can see here. So we have to select EU Frankfurt 1, which is already here. So I will copy and paste. So I want to generate a new API signing key, so to authenticate, because it's a new fresh installation. The default directory and the public and the private key are going to be generated there. Okay, so now it is there. I need to copy the public key into our tenant. Okay, so I will do a cat. It is our home oracle.oci. OCI, we have here the public. So I'm gonna copy this and I will put it in my user. Okay, I will show you how to do it. So if I go to my user, here I have the API keys. So if I do a public one, so I do a paste here, so they are going to be, I'm going to be able to run commands as I have the public and the private key. So if we check the fingerprint that was already here, okay, we can see that is the same. So it is already configured, okay, and synchronized. So let's test if it works. So what we're going to do is to upload the export into the object storage, okay. So I'm gonna go in the folder where I have the export directory, which is here. I'm gonna upload it. So in the OCI, I wanna do the object storage. So I'm gonna do an object put because I want to upload it. The file is gonna be the export DMP, and the bucket where I have defined before it was DB. I think it's dash dash. Let's check it. Okay, so it was not double dash. So let me double check the help. I think as you can see, this is a help command. So in case there is something, okay. Okay, what's the bucket name? What's the one that was missing? Export DMP and the bucket name was DB, was the one I created before. Okay, so it is uploading our object. Okay, so let's see how is the upload. So if I go to the object storage, okay, we can see that it's already there and it's already uploaded. Okay, we saw that it is really fast. Okay, automatically split into six files in order to make it faster, and we upload quite a big file in a short time of period. Okay, so now that we did the export and also we're uploading to the cloud, what we're going to do is to import it into the autonomous database. Okay. So as I said in the video, the first thing that we have to do is to create the credentials. Okay, I'm going to show you how to do it. These credentials are done via PL/SQL. Okay, so if I go to the autonomous, I will go to the SQL Developer Web, uh, so I can run it automatically there. So tools, SQL Developer Web. It's not asking for the credentials, I think because of the cookies. Okay, so this is the PL/SQL. The PL/SQL is called a DBMS Cloud Create Credential. Okay, I'm gonna show you how to do it. It's begin DBMS Cloud dot create credential. Okay, and I'm gonna put it like this to finish, and it asks for some parameters. So the first one is the name, credential name. This is a name that we're going to define for these purposes. So for example, says my credentials in plural. Okay. So the next one is the user, which is my user in the Oracle Cloud. Okay. That I'm going to copy from my user directly. If I go here, if you have the Oracle identity, you have to copy it also. And then finally, we're gonna need a password. Okay. So this password is not defined into the password that we're using for login and so on, it is an authentication token that we have to generate, okay? So if we go back to our user, here we have the authentication token. So we need to generate one. And this is the one that we need for the credentials. So if I click into generate token and I give a name, for example, my credentials, okay, to be sure that are the same for the same purposes. So I will click on the generate token and I will copy them. This will never show before again. So copy it in a safe place, or maybe you need to create a credential every time that you need it, and you will see it's a specific password and it's not very easy to remember, and so keep it safe, okay? So what I'm going to do is to run this specific create credential, okay? So I can access to the specific object storage, okay? Also, something I will have to do is to define to the autonomous that we're going to use this specific credential, okay? So there is a command which is explained in the documentation, which is alter database property set default credential uh, equal to admin dot and the name, which is my credentials, okay? And with this, I'm saying, telling to the autonomous that I'm gonna use that specific credential in this point in time. Okay. Now, also something to consider as we're going to run the import is the autonomous database run in the port 1522. So we need to open that specific port. Okay. Also, so if we go to the network into the VCN, okay, I'm gonna select the public network that I created in the beginning. So there is a public subnet. So there is a specific list, and we will see that the port is 1521 because it's already generated when we create a database before. So we need to create one, but for the 1522. Okay. So if I add a new one with destination port is that one from any IP. Okay, you can configure your security rules depending of what you need. Okay. Sorry, I didn't modify it. I copy and paste 22, and I have it here. Okay. So this is ready. So what we need to do is to import. Okay. I think we have everything already in place to start the import. So as I was saying, if we use the Cloud Shell, we can use the SQL client, which is already there, to run the InPDP. Okay, so in order to run the InPDP into the autonomous database, what we have to do is to first of all to download the wallet. So with the wallet, we'll be able to connect into the autonomous database to run the import, and then even we will define the URL of the data pump so we can run the import. Okay. So the first thing that we have to do is to get the wallet. Okay, so if you remember from the other videos, we're going to use also the OCI CLI, which is already installed and configured in the Cloud Shell, not like before in the machine with in the 11G that we have to install it. Here is already configured. So let's download the wallet. So for example, let's run OCI DB is autonomous database generate wallet autonomous ID, which is the ID that we can copy it from here, which is the OC ID. Then we have to define the password. For example, something like that. And the name of the file, wallet.zip. And if I didn't miss anything, I will download the, okay, maybe it's not minus autonomous ID. Maybe just one simple dash. Maybe I'm missing something. OCI, we'll use the helper because I have very bad memory. Database, generate wallet. Ah, I was missing database. Okay. Minus autonomous database ID. I think I have it here. Okay. Minus password, for example. This one. Minus file. Wallet.zip. Okay, we have it here. So let's unzip it. Unzip wallet in the directory, for example, what we're going to call wallet. I have it here. Okay, so we need to modify the SQL because here is asking for the directory where the wallet is. Okay, so in this case, the wallet is here, so we have to point to that specific folder. So if I do v SQL to modify it, okay, and I'm gonna change this. Okay, so we are pointing here. So let's check that the changes were made. I think not. Okay, okay, okay. So we have it there. Now with this configuration down, we have to export the TNS admin pointing to here. So export TNS admin equal to home. Have it here. I will copy and paste with the wallet. So I will be sure that I'm not doing something wrong. Okay. Equal dollar. Okay, we'll have it already there. So with this configuration, we are already able to do, for example, let's do a TNS ping, for example. Maybe I don't have the tool here to test it, but let's run the in PDP directly to run the import, okay? So what we have to do is with in PDP, I will run the admin with the password, it is pass the with the dash, okay? To the ORCL high, okay? I have to define the dump file, okay? Which is, I have to define which is a standard, which is the default credential. And here I have to define the URL, okay, from the export that I'm going to copy here. So if we go to the object storage, I click the DB bucket, and in the object, in the export, I will view the object detail. I'm gonna copy this URL. Okay, I'm gonna exclude the same parameters that we saw in during the import, during the export, sorry, cluster, DB link, and also there is some default configuration is transform. You can check in the documentation what is the meaning of this to make it not so complex. So if everything is nice, so we can see this is connecting to the 19C, which is the autonomous. So we should be able to run to see the how the import is going. Okay. So these are the steps you have to follow for the import. So it's gonna take some minutes. So I hope you enjoy, you have the detailed information about how to run the export and import, okay? And then if you have any question, don't hesitate to contact us. So as you will see, as I didn't run in parallel, it's gonna take, but once it is finishing or starting to import the data, we will keep it here for the video. As you can see, it is processing all the objects. Also, there are some privileges that we cannot give because we don't have the access to the system into the autonomous. There are some issues, but this is normal issues due to the restrictions that the autonomous database provides. Okay, so I want to keep this in the video because you will see maybe something strange, but it's normal. And in a few seconds we will see that it's starting to import the rows. So that's why it's very important to validate the autonomous database with the schema advisor to check that everything is fine, to also to read carefully the documentation because it's not exactly the same, okay? For example, here we saw that there is not a specific table space users. So this was the warning that we have, that everything will go to the table space data. And this is automatically done and managed by the autonomous database. So although we have an issue, an error here, we will see that the data is imported, okay? Once it is finishing off processing all the objects that are not so many. Okay, so we can see here that the import was done with the error that we were expecting due to the table space and so on, okay, and all the rows that have been imported, okay. So this is all the video for today, so thanks for watching.